So now that we've learned how to take the integral of a constant and of a power function, we have a bunch more rules that we want to learn, okay?
Is this a different document?
This is now rules for integration day 1, okay? Now, don't let this intimidate you, okay? It seems like a lot of rules, partly because they're showing you where these rules come from. Notice on the left-hand side, they're doing derivatives. Therefore, on the right-hand side, we have this rule for integration, okay? So since the derivative of a linear function is a constant, the integral of a constant is kx plus c, a linear function. Since when I take the derivative, I multiply by the exponent and subtract 1 from the exponent. Here, when I integrate, I add 1 to the exponent and divide by the new exponent. Okay, there's an opposite or inverse idea here. Okay? But this applies to other things as well. For example, e to the x. The derivative of e to the x is e to the x. So guess what the integral of e to the x is?
E to the x plus c.
E to the x plus c.
Plus c, guys.
Okay, plus c. The derivative of the natural log is 1 over x. Therefore, the integral of 1 over x is...
Natural log of x plus c.
Yeah, natural log. Now, this one does have one item that we do need to be careful about, and that is the absolute value of x.
Yes.
IB does not make a huge deal of that. In fact, if you look at the answers in the back of the textbook where our homework problems come from, they often will leave it out, okay? They really shouldn't do that. The reason why we need that absolute value there is because the natural log is only defined for x is greater than 0. If you remember your parent function, there was an asymptote at 0, okay, asymptote, and it looked like this. All right, so if I have x equal to a -4 or something like that, I can't take the natural log of -4. I have to take the natural log of the absolute value. All right, and that'll be significant later on when we get into doing definite integrals and we're actually plugging values into these antiderivatives. Okay. The derivative of sine was cosine, so the integral of cosine is sine. The derivative of negative cosine, the derivative of cosine is negative sine, so the derivative of negative cosine is negative sine, so positive sine. So that tells us that the integral of sine is negative cosine, all right? Now, with sine and cosine, this is a real easy way to remember derivatives and integrals. If you just have sine, cosine, negative cosine, just put them like that, it's like a cycle, okay? If you go down, you're differentiating. If you go up, you're integrating, okay? So, if you look here, the derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, the derivative of negative cosine, go back up to the top, is sine. However, if I'm integrating, the integral of sine is negative cosine. The integral of negative cosine is negative sine. The integral of negative sine is cosine. And the integral of cosine is sine. All right? So, the integral of sine takes us back down to negative cosine. It's like a big circle. Okay? So, if you just write that on the side of your paper or something, that helps you think it through. Okay? Alright, so how do we use these rules? Okay, well there's a couple of things with integration, and there are a number of different properties that we can look at that'll help us. Alright, so for example, if I'm trying to take the integral with respect to x of 2 sine x minus cosine x, all right, one of the rules that we can use is that if you're taking the integral of things that are added or subtracted, you can actually split that up into separate integrals, okay? And as we've already seen, if you have a constant times the function inside your integral, you can pull that function out. So I could actually rewrite this as 2 times the integral of sine x dx minus the integral of cosine x dx. Okay? Now we're down to the point where these are rules that we just saw. What's the integral of sine? Minus cosine. So that's going to be minus 2 cosine x minus, what's the integral of cosine? Sine. So minus sine of x plus c. Don't forget the plus c. Okay? For part B here, if I wanted the integral of negative 2 over x plus 3 e to the x dx, I could rewrite that. There's a negative 2 in the first part, so I'm going to make that negative 2 integral of 1 over x dx plus 3 times the integral of e to the x dx. Okay, notice how I'm using these two properties that we've just talked about. I can pull constants out, and I can separate sums or differences into different integrals. And now what I'm taking the integral of, I have a rule for. The integral of 1 over x dx is what?
The absolute value plus c.
Good. The absolute value, or the natural log of the absolute value of x. So I have negative 2 ln of absolute value of x plus 3 times, what's the integral of e to the x? E to the x. And then we got the plus c.
Would it be plus 2c, or would it be just plus c?
Well, that's a great question. Okay, if we have multiple integrals, do we have to add multiple c's? Since c can be anything, the answer is no. Because 2c, c, it's not going to make a difference. Okay, so just when you're doing multiple integrals like this, just do all of them and put a plus c at the end.
C. Okay.
All right, you got it.
Bad joke.
Okay. Now, there's another thing here that we have to deal with, and that is cases where we don't have a nice rule for it. Okay? But the thing is, this is where some algebra comes into play, and you just work with it until you get it to look like something that you do have a rule for. For example, this first one here, if I have the integral of 3x plus 2 over x quantity squared, I can FOIL that. There is no chain rule for integration, so I can't do the integral of the outside times the integral of the inside. It doesn't work like that here. Okay? But I can FOIL this and make that 9x squared plus 12 plus 4 over x squared. Okay? And now I have things that I'm able to take the integral of. Okay? The integral of 9x squared is going to be 9x cubed over 3. The integral of 12 is 12x. And since that's a 4x to the negative 2 power, it's going to be 4x to the negative 1 over negative 1. Okay? So with a little bit of simplifying, I can say that my integral is 3x cubed plus 12x minus 4 over x plus c.
Yeah.
Okay? So if it doesn't look like something you have a rule for, try to work with it until you get it to a point where you do have a rule for that. Okay? Same thing with B. since there's a monomial in the denominator, I can split that up. I can reduce that first part. 2 minus a half is going to be 3 halves. And this is 2x to the negative 1 half. Now I have things I can use the power rule for. Okay? The integral of x to the 5 halves. Oh, not the integral. Just x to the 5 halves times 2/5. 2x to the 1 half divided by 1 half is going to be times 2. So that instead of a 2 there will be a 4. Okay, plus c. So again, if you don't have a rule for it, you do some algebra and get it to a point where you have something that you do have a rule for. Okay?